one with the 220 knot or 220 mile per hour jet. So unbelievable, just an unbelievable event. I wonder, I mean, they had to know this was happening and they were going to get there way in advance. But maybe when you get there at 4:30 instead of 6:30, there's nobody else to compete for gates, so it didn't matter. Because I always get the sense that when you're flying any distance, they want to try and manage who's going to land at the airport because it's, you know, there's a lot of bookings there, but not at 4:30 a.m.
I heard that there was confusion listening to BBC that when they landed so early.
Oh, is that right?
There was like confusion and.
How can this be the flight? That sort of confusion?
Yeah.
Oh, wow, that's amazing. So that was last week with a roaring North Atlantic jet.
Also,
and then, yeah, go ahead.
I was going to say about flights of that sort. I mean, there's often, if you're just on the edge of a really strong jet, it can be a lot of, for lack of a word, turbulence.
Oh, yeah.
And I guess they have to find a sweet spot of getting the maximum speed, with the jet, so you can, not have a significant fuel cost. They have to balance that with finding an altitude and a location relative to the core that's not particularly bumpy.
Yeah. So that's skillful navigation. Sort of reminds one of Luke Skywalker saying, this reminds me of crop dusting back in the Something Canyon, right? You know what I'm talking about.
I'm more Star Trek than Star Wars.
Well, whatever.
Back home, I think you said.
Yeah, he's back home, but there was a name for the canyon.
Right,
I don't
yeah.
remember what it was, but anyway, that's when he's gonna just about to blow up the Death Star. All right. So look at that big disturbance that was part of the story over the week too, over in the North Atlantic. That one was down to low 930s, I believe, right?
Yeah.
And the next one that's maybe in the forecast, I don't know if it still is, but there was going to be in the 9 teens. So some of the lowest pressures we've ever seen, far outpacing almost every tropical cyclone that's ever populated the surface of the planet. And certainly the intensity and scale of these disturbances far out exceeds them as well. So it's pretty interesting. And then one last thing on the broad scale, this is the colored infrared. So you can see where it's cold just by the color scale. So we're in the 250 Kelvin range, so minus 23, minus 30 C. And you can see it kind of evolve during the day. I don't know if you can see the day. These are going every 10 minutes, but you can see late in this period, we're going to have the coldest, just about the coldest spot in the Northern Hemisphere is going to be over Madison. And that was late last night, early this morning. So we got pretty cold. I think Greg said the temperature of the airport was minus 11. And the record is minus 13. So out of nowhere, we almost had a low temperature record for a day this winter. That's unbelievable. The 850 cold pool is still third warmest ever for the hemisphere. We're not going to move to first or second. They're far outstripping us, and fourth is pretty far behind. But I don't know. I mean, if something goes crazy, we might drop to fourth.
Here comes the blue.
Yeah, here comes the blue. So look at that. That's cold, and it's even colder to the north. And that's pretty darn cold right there. A little bit colder, perhaps, just to the southwest of Minneapolis, but that might even be clouds. I don't know. But there we are, right in the middle.
Yeah, and interesting, this was something that we saw, we looked at the week ahead forecast at the end of last week's Weather Watch. We were talking about this cold surge coming in on Thursday.
Yeah.
And Friday.
Yeah, it was right on. And there's the MCS near Sierra Dakota. That's pretty awesome. Okay, so let's go away from the global view. Thanks, Pete. And we'll start looking at some more regional ones, but not this one. We could spend 2 hours looking at the satellite. We just can't do it. What would you like? Let's take a look at the continental U.S. satellite first. And so really the only cloud cover across the country today is this continuous stream of clouds from the western Gulf of Mexico that goes all the way along the Atlantic coast, and it's embedded in this highly energetic flow over the North and Central Atlantic. So it's all kind of tied in ways that don't present themselves as obvious on the satellite photo. Then you can see the fresh snow that is just north of St. Louis, just south of Kansas City and into central Kansas. Let's see, Indianapolis maybe was on the border of the snow. It's down in central Illinois. Same here with Columbus, maybe had a little bit. So new snow over much of the central part of the United States. And then here, don't despair. There's snow there. It's just there's a lot of pine trees too, so you don't see it. This is all farm field, so it looks different. And the same with the Dakotas and Minnesota. So with cold air coming over, we had perfect conditions last night to bottom out. And we also have a low elevation airport. But that's where the minus 13 was set. So those rules are all the same. So we got down close to an all-time record for the day.
That was minus 12
night.
actually this morning.
It was minus 12?
At my house.
Oh, at your house, okay. So that's your record for this winter?
Yeah.
For the year? You don't know yet. You don't know.
Don't know.
Because the last time we were at zero was December 18th, so we finally got below zero.
Did we get that cold in early November? I know we were single.
We got +1. Yeah. It was never zero in November, +1 on the 19th or something like that, yeah. So 0 on the 18th of December, then -11 on the 14th of February. There's some higher cloud and some light snow we'll see on the radar in a minute falling over parts of the northern part of the continental Rockies. And then we'll go to the west coast and see what's lurking out to the west in just a second.
Yeah, and just another thing to point out, over parts of Nebraska and Kansas, that area of cloudiness, and that's,
Yeah.
I think, the leading edge of the warm advection that's about to start over us.
Oh, yeah, that's
Warm us
probably
up
right.
tomorrow.
Or maybe the leading edge is further to the east, and this is the leading condensation edge
Right.
because the air is so dry. That might be what's going on. Okay, can we go to the west coast satellite feed, and then we'll go to the radar. So here's the west coast infrared, and a couple of different things are of interest to me. We continued northerly flow in a trough structure over the western part of the United States. I think you see that at 500 milliwatt. Here's kind of a broad anticyclonic leaf of clouds, not an obvious cyclone in the Gulf of Alaska for the first time in several days, actually. And then there's a really nice cyclone in the Bering Sea. I don't know what its depth is, but I would guess probably 970 or lower. But not as well put together as some of the ones we've seen most recently this week, actually, in the Pacific Northwest. So, and there's Hawaii, just to give you a perspective. That's the northern boundary of the subtropics. So the IPCZ is not particularly active. That's been a characteristic of a lot of our Friday discussions. I don't know if it's been true on the non-Fridays and therefore characteristic of the season, but at Fridays anyway, we've intercepted it at periods of relative inactivity. That's interesting. So can we take a look at the continental radar reflectivity next week? And the only game in town is not really in town, it's off the coast of the Carolinas. So this is the western flank of that cloud mass that we saw in the satellite picture, and it's precipitating right over the Gulf Stream. Maybe some of the convection's enhanced by the warm waters there, maybe not. We'll see when we look at some other shots. And then light snow in eastern part of Montana and a little bit of scattered shower activity south of the Puget Sound, the Olympia area, and then the same maybe is occurring somewhere in the valley, although a lot of this looks like just scattered return. Same with down in the Phoenix area. And then there's a little bit of lake effect snow in far western Michigan, not too much else in the lee of the Lakes Ontario and Lake Erie. So a pretty benign day, probably a day where you could travel across the country without too much delay anywhere. There's just not really anything serious happening anywhere except for cold. That would be newsworthy. Can we take a look at the super peaks next, Pete?
Surface or upper air?
No, let's skip the surface. Let's go to the upper air thing. Let's start at 500 millibars and we'll climb up and down. So here's 500 at.
Like the last several weeks in a row, that's not looking good.
So here's 500 millibars from this morning at 7 a.m. Very intense baroclinic zone along that cloud band and the roaring North Atlantic jet. So look at how cold it is. It's minus 35 at Caribou, Maine at 500 millibars. And then the thing that's more impressive is the temperature contrast. This is the minus 35 isotherm. This one here is the minus 15. So there's 20 degrees of temperature contrast across a really narrow swath. And that's consistently the case along much of this jet. So I think when we go to 300 millibars, we're going to see a really intense upper level wind speed maxima. These are all 130, 140 knots right here at Sable Island or wherever it is in Nova Scotia. Maybe it's Halifax. That's 140 knots at 500 millibars, which is a pretty strong wind. And then along the Pacific Northwest coast, particularly British Columbia coast, as we saw a little bit in the satellite picture, the tendency for cloud elements to be moving to the southeast is verified here by, not as deeply as I thought, but there's a nice baroclinic zone in northwesterly flow stretching from the northern part of British Columbia down to northeastern Oregon. And there's a tendency for there to be slight geostrophic warm advection along the length of that, so the air is rising right through the core of the jet, most likely, and consequently may not develop very much of an upper vorticity feature. But that can change as you have downstream of the micro ridge. There's substantial subsidence and there's less subsidence downstream. And so variations along the stream of how much subsidence there are can rearrange the thermal field. Richard Tuno was the first to really think about that. It's a really excellent argument about how one sets up the preferred thermal advection in the northwesterly flow. It's really a long flow variations in omega that do that. It's not vorticity. Generally I'd say this, as I mentioned a couple of times during the fall and the winter, this has been a very wavy winter across the continental United States. I don't do my measurement in a regional sense, but I could reconstruct it, and I would not be surprised if this was one of the waviest flows, persistently wavy flows from, let's say, 30 degrees west to 140 degrees west for the wintertime that I've ever seen. I wouldn't be surprised if it comes out.
And that's kind of manifest in the sort of sensible weather we've experienced, in that we haven't had really long sort of regime-like weather, which is
That's
stuck
right.
into a given pattern.
That's right. Which you would imagine would require a large-scale anomaly that's
Right.
somewhat persistent. And we haven't had that. So, yeah, that's a really good point.
But although it's been wavy, it's short wavy. It's more of a
That's
high
right.
index pattern.
That's right, very high index, I agree. That's right. It's just unusual all around, in a lot of different attributes. That's one thing that stood out to me, but it's anecdotal still. I mean, you could go back and make it less anecdotal by doing the real calculations and measurements, which is a reasonable thing to do. I'd like to maybe do that.
Look at that really,
Stay a moment.
really extensive narrow ridge that extends from the
Right in
eastern
here?
side of the map, no, just in the subtropics, across Cuba, then all the way out into the central.
Oh, right here?
Look at it, you can see the
Yeah.
the ridge, I mean, you can see the westerlies, the easterlies there, and then the westerlies by Bermuda, but it's just.
Oh,
very-
right, yeah, right here. And that's where we saw a really interesting eruption of convection, and prolonged one. Well, prolonged because they were every 10 minutes. But pretty intense eruption of convection. It almost started to look like it had a leaf structure to it at the end, and that's way down here at 20 degrees north, in the middle of the winter. And I would say quite removed from anything that's going on in the polar westerlies, even though they were highly amplified. But that's not really the factor there. So that is interesting. Yeah, it's really interesting. It's like a little monsoon on the Yucatan Peninsula. Okay, can we go to 300 millibars? So what the expectation is with that strong temperature contrast in the southwesterly flow, we should have a really strong jet. And we do, 201 knots. This is 190 at, where am I? That's Sable Island. So it was 140 at 500, it's 190 at 300. All of these are 180, 180. That's at Chatham, Massachusetts. So these are some of the strongest winds that I think some of these stations have seen with regularity. And it's probably been more than once this month. They've had extraordinary wind speed maximum over the western North Atlantic. So 201 knots at 300 millibars. We have to go higher and see if it gets higher at 250. Let's try that. No, 197. So it's kind of a uniform 200 knot wind jet core stretching at least from 300 to 200 millibars. What about up to 250? Let's try 200. I suspect it won't be as high there. I think this is mostly a polar jet. 167. So that's mostly a polar jet structure or some kind of amalgamation that is limited to about 250 millibars for its jet core.
That's not exactly what it is, because it drops to 100 knots, 150 knots, but then it goes all the way up into the upper stratosphere.
Yeah,
So
but that's not a polar or subtropical jet.
Well, there is a connection to the thermal wind field so that it doesn't drop off above that level as much as it normally would. So there is a continuation of that jet all the way up into the 30, 35 kilometer elevation. At some level.
Okay, that might be, but I wasn't talking about that, so I don't mean.
Well, yeah, but I think it's related. I think that's what I keep saying. I think these high wind speeds at low levels are driven by that thermal wind field at high levels. That's not allowing it to drop off above that point, and that keeps it stronger at some level all the way up into the polar night jet regime. To me, when I look at all these jets, the connection is just undeniable. This is the only place on the globe where they're connected like that, and they're very high. And maybe I got it wrong. Maybe it's these jets are so strong that they're extending to the polar night jet. But you see the polar night jet also reaching down, and so I think there's a relationship that needs to be studied.
Yeah, I wouldn't deny that. I think that we've been confined to the lowest 900 millibars of the atmosphere for a long time. It's always good to expand one's horizons. If we go to 200 millibars, though, we're going to see that's where the temperature contrast changes sign, I think, right? Because we're minus 47, minus 54. So it's warmer on this side, colder on this side. So we're already having a reversal of that underlying jet.
Yeah.
So I don't know how you add on top of that anything that penetrates this reversal and makes the wind speed
Well,
stronger.
as you get higher, it reverses again, right? Because then it's colder to the
Right, but what does that matter for the wind speeds lower than this elevation? That's what I don't think I understand.
I don't understand you.
Oh, okay.
I mean, I don't know. I do think there's a relationship when you integrate it all the way up. And it's striking when you look when you look at the total wind field, not just constant pressure mass, but you look at all the wind field all the way up, you can see they're connected in some very intimate way that we have no theory for that I know of.
Yeah, well, that's a fair statement. That's probably a fair thing to say.
But visually, you can see they're connected, and it should be pursued to try to understand how they're connected.
So maybe, one thing that could be done in the adjusting project would be to look at how anomalous is the horizontal temperature gradient in that area through the deep layer. Is
Right.
it weaker now than it otherwise would be, so that you get some linking between those jets, or is it something that's, again, just how anomalous is it?
Well, yeah, we saw a cross-section together early this week where the isotopes were flat from 100 to 50 millibars. They were just flat over a huge area. And that did suggest that's got to be anomalous. You'd think that they would have some gradient in other times. So I bet you that's right. We were even thinking about that.
And there's that, and when you get up to about 30 kilometers, there's a very cold anomaly over the poles, as there should be, from the polar night. And so you see that it almost, depending on the contrary interval you look at, it looks like an ozone hole when you look at the ozone.
Yeah, we saw that.
And so it's very, very cold up there, and that's what's driving the polar night jet. But you see the polar night jet merge with this jet, they're connected at lower elevations. So how is that, what's driving that connection?
I don't know. And what is the nature of the connection? It's maybe a fundamental question too. I'm not sure I understand that yet.
It seems far
And then
away,
the second one
at
comes
30
after that.
kilometers, but it's only a few millibars away
Yeah.
in terms of pressure.
Yeah, well, that's right. But that's big. That's big.
One of them is fake.
Yeah. Right. Okay, so no matter how it's connected, and it is a good research question or a question to consider, no doubt about that, but there's a 200-knot tropospheric jet off the east coast of North America and headed towards the British Isles again. So if you're going to board a jet at JFK today and you're going to fly out to London or something like that, you're probably going to have a shorter ride than you'd expect, again, just like last week. So that's pretty good. And I'm sure that the airlines are well aware of that, and they're getting everybody up to the right level and following whatever the right flight path is through a jet region, because it should be more turbulent. Be careful, but you can really take advantage of that.
And the other thing is, I mean, this is something that, to the extent that this is predictable on the 2 or 3 or even in the sub-seasonal timeframe, airlines are interested in knowing about these sorts of patterns,
Yeah,
because they can make decisions on fuel purchases, things of that sort of thing.
That's right.
Take advantage of this.
Exactly. Okay, so that's our tour of the upper levels. Let's go down below 500. Let's go to 850 first. Pete. Okay? And if you see reflection of the extraordinary temperature contrast, this is really what's organizing the cloud band. So now it looks like there actually is something substantial to help explain what we saw on the radar. That this temperature contrast is not inactive. This substantial cold advection on the west side and not very much warm advection on the east side, as the isotherms are more parallel. They're not actually parallel, but they're more parallel to the geopotential height lines on the warm side than they are on the cold side. So there's differential temperature advection, increasing the horizontal temperature gradient, and the response to that's a thermally direct circulation. So on the warm side, there's going to be a precipitation band. And sure enough, we saw that right off the coast of the Carolinas. And the cloudiness in the satellite picture was evident all the way out to south of Greenland. And that's not surprising because that's frontagenetically active. Most likely, one could do a calculation to verify it, but most likely to a lesser extent further north, but to some extent all the way along that Barren Point zone. And then here we are at minus 21 at near Detroit, minus 20 at Green Bay at 850. I've seen colder, but you know, you can't complain when you get below zero for the first time all year. That's okay.
It's a reason to complain.
Huh?
It's a reason to.
Well, for most people, I know I hold the minority view on that. So minus 20. And then the more important thing is look at the extraordinary warm advection that's occurring at 850. Now, granted, some of these locations here are above that level. So this is somewhat of a fictitious analysis. What's not fictitious is that in the lee of the Rockies, with reasonable flow across them, there's going to be a pressure trough. And there's also going to be a warm thermal ridge. And so both of those features appear to come out of this analysis, even though it's ugly. And to the east, there's warm air advection that's rather substantial over the whole, all the way from Lake Winnipeg down to, I guess it stops probably around Oklahoma, Arkansas border. So it's a pretty wide region of the Northern Plains that's experiencing decent warm air advection. And as Michael pointed out, we saw some clouds actually showing up in Kansas and Nebraska right at the beginning of the warm advection. So this air is, it's got a 5-degree dew point depression. It's not really that dry. It's drier as you move further to the north. It's a 36-degree dew point depression at Minneapolis. So this is cold, dry air. This is warm relatively moist, although not really moist air that is further to the south and west. So the big warm advection is the reason why this afternoon, late this afternoon, is going to feel a lot better at the bus stop than it did this morning, because you're warming up. And that's a nice picture that we're going to see throughout the weekend. I think. This is just the beginning. So we had a momentary dip into the really cold air, and then it's going to quickly be erased, it looks like, as we move forward. Now, Pete, maybe it would be wise to go to the surface map and take a look at the temperatures across the region so that we can see, to some extent, some of the effects of that warm advection. So we're still struggling to see 10 degrees, but if you go all the way down to about where the 850 warm advection is starting, well, you're already in the mid-20s, some places 30. So one gets the impression that there is a warmth that's on the horizon. Look at this, 39 in far southwest Kansas. So this is right where that warm axis is. You can even have some 50s in Prairie, Colorado. So, and that's maybe the axis of the warm air in the lee side trough, goes right about like this. And let's see, you don't really see the winds so obviously, although the southerly winds out ahead of it are obvious. And so there's warm advection and southerly winds that are going to carry this cold air, carry warm air over it and carry the cold air away eventually. So that's nice. So I think that's all I have. Since there's no organized weather systems across the central part of the continent, I don't really have any, I didn't have time to think about looking at vertical motion fields or anything else like that, so I think I'm done.
Okay. Yeah, I'll be equally or even shorter with a discussion of the upcoming weekend. Let's go to UW-AOS on this. I'll go down first to the meteorogram, everyone's favorite first chart to look at.
Meteograms are nice, yeah.
Yeah, so on the meteorogram, we can see the temperature, again, degrees Celsius. This is out through 60 hours from 12 this morning, so it ends Sunday evening, 6 p.m. Temperature, dew point, and then accumulated precipitation. As you can see, for the most part, this is going to be, this is forecast to be a rather dry weekend. But the one sign here is the moderation of temperatures and the fact that we're also going to be in a period tomorrow evening when otherwise you'd expect it to be cooling off. We're going to pretty much have temperatures staying level with time. They're not going to be actually decreasing significantly. So strong warm advection is going to start off. It's going to overcome the radiational cooling and keep us warm through the weekend and get increasingly warmer over the course of the weekend. And the dew point's also beginning to recover. And we have to watch what's going to happen at the end of the weekend with maybe some light precipitation, snow, or maybe even freezing drizzle, I guess, would be a possibility. Which would not be too pleasant. Let's look at the time height section. You get a sense of any significant.
What about fog? We have the temperature and dew point running parallel for about 12 hours there. I wonder if we're going to get fog on top of the snow.
Yeah, I haven't looked carefully at that, but with a warm advection, and you can see at least in the boundary layers in the forecast, this is the time height section. Red is relative humidity. We start off rather dry initially, very low relative humidity, below 70%. And then over the course of the weekend, starting tomorrow morning, those temperature dew points getting close to each other, close to saturation. This isn't forecasting 100% relative humidity, but there may be certainly some clouds, perhaps, but the relative humidities are going to be going up over us. So it doesn't mean it's going to be stopping wet, but it's certainly going to be closer to saturation. And then this column deepens in terms of the higher relative humidity as we get closer to the end of the weekend when we're anticipating that precipitation. Looking at the upper part of this diagram, that green line again is an dynamic tropopause, and it's surprisingly quite elevated over us at this point, but it begins to descend somewhat, which is more of a hallmark of maybe some sort of upper trough arriving, but it's not particularly a intense upper trough. You can see the column does cool a little bit while we warm up to the surface, so that's also an interesting pattern, maybe a little bit of atmosphere becoming more unstable. Not unstable, but just less stable over time. Cooling aloft, you can see the isotopes are popping up, but not much happening down here, so weakening stratification occurs. And that's also evident if you compare the stratification early in the period under this deep anticyclone and the stratification as measured by the spacing between these yellow contours, which are isotopes, lines of constant potential temperature, later in the period. So just looking at this looks pretty quiet and pretty uninteresting. The only nice thing is the warm advection and increasing temperatures. Let's take a look at the maps. We'll start at 500 millibars, and maybe we'll first do just a loop, a GIF, animated GIF. Of course, it's a little rapid, but you can see the progression of these features as continuing progressive pattern across the country, with weather systems not really sort of locked in place. Initially, you see the upper trough that's over the central U.S. Heading eastward, and other features beginning to move in. You have these color patterns or vorticity, a measure of sort of a local rotation in the atmosphere. And you can sort of indicate where the troughs are arriving as you see those more brightly colored patterns arriving. And at the end of the period, we get this bit of a blob that goes by that gives us maybe some precipitation. But again, this is a very aggressive pattern. Nothing's going to stay the same for very long. Let's take a step through these little bit. We'll start
They're
out
all
with-
stretched.
Yeah,
Every
not
single
very-
vortex structure is stretched out.
Yeah, none of them are really balling up to the extent. Let's start at 12 hours in the forecast. So this is 0 to 9. And here's that strip of vorticity that's also associated in a very, you may say indirect way, but well downstream of it is the surface front that's associated with this trough pattern here. You've got wide separation there. But here's the ridge axis just having crested over us at 500 millibars by early this evening. And the westerly flow that's going to be coming beyond that. This westerly flow at 500 millibars at lower levels, again, it's downsloping across the east of the Rocky Mountains, so it helps to create that sort of region of warmer air that's going to help eventually be affected over us. And this feature might be something we'd be of interest in sort of watching carefully, but it looks like it's going to pass more to our north, and we'll see how we step forward. Let's go ahead to tomorrow morning, 12 to 12 forecast. And you can see it was a little bit more circular earlier. Now it's gotten stretched out, and it's a more linear pattern. But again, it's well to our north. You also, if you're looking at patterns of vorticity advection, obviously we'll look at this by the thermal wind, and we could do that. But even at this level, you can see the advections are largely, the winds are largely parallel to the isoclastic vorticity, so not much in the way of significant vorticity advection downstream.
This whole series of waves is flexing momentum poleward
Correct,
in the
tilt of the
troposphere.
spring.
Yeah,
It's something to ramp up the jet at higher latitude.
yeah, I don't know. It's so interesting.
Okay, let's go to 36 hours in the forecast, 500. And the trough passes by us, but again, there's not much effect, but there is, we saw the tropopause lowering over us, and that's going to be associated with these heights that have fallen over the upper Midwest. But they're going to fall with very dry lower tropospheres. You're not going to get much in the way of significant deep vertical motion that will lead to precipitation. Okay, so that trough axis is bias. It's past bias at this point, and then we're back in this northwesterly flow at 500 millibars. We'll go to 48 hours. Again, this is really, really quiet. Relatively quiet. The trough passes by, and then we have some more upstream vorticity elements. This, you can see the advections associated with this one are a bit more prominent because the flow is crossing the isoplasts well upstream of us. Let's go down to, actually go to 60 hours to end this sequence of maps. Yeah, and as this arrives, it also gets stretched towards the advection with a little bit less prominent, but maybe some unsettled, whether it's the trough axis is now with bias, and we have this next lowering of heights well to our northwest. Again, this is really, in my mind, a quiet pattern, which means by Sunday something dramatic is going to happen. It's not forecast by the model. Let's look at the surface map.
That generally westerly flow always means a little warmer than normal for us too in the wintertime. And it's reflected.
Yeah, so we look at here, this is 500 millibar, 1,500 millibar thickness. Those are the yellow contours here. Sea level pressures in white, and you can really see the dramatic warm thickness advection that's starting across the plains by this evening, all the way from northern Texas, Amarillo, all the way up to International Falls and beyond into southern and south and western Ontario. It's really going to warm up. There's more advection that's occurring in advance of this next. The trough that's set up a little bit the Rocky Mountains. This anticyclone now moves eastward. This is accumulated precipitation over the time period ending at the last 6 hours ending this time period. Again, with that frontal zone that was off the east coast. Let's go ahead to 24 hours tomorrow morning. And warm advection continues. We do have a cyclone well up into Hudson Bay region, but trough associated with it is well toward northwest. You can see sort of make out the cold front associated with this, and you can see there's differential temperature advection, at least geostrophic advection implied by the advection. of the thickness by the sea level pressure. And so that's going to, that's perhaps one of the reasons you're seeing this area of precipitation ahead of the front. But all this precipitation is largely low toward north. We can verify that looking at some other models if you want to do that. But so tomorrow should be a really nice day, maybe some clouds toward north at that point. Let's go ahead another 12 hours. 36 hours by tomorrow evening. The front, to the extent that you can sort of identify it, looks like it's sort of washed out a little bit. There's a secondary trough that's back to our north where the cold advection gets prominent again. But we've gone from warm advection to generally neutral advection. It's not really strong cold advection. It's weak cold advection at best, but almost neutral advection. But again, the secondary, so we call it front, but still to our north. Okay, step ahead another 12 hours. So Sunday morning, and by Sunday morning, again, weak cold advection over us. Again, it's pretty much neutral temperature advection, or thickness advection at this point. And the model forecasts some light precipitation to our north, not much over us. With the anticyclones over the southeastern part of the United States, sort of return flow around that. Southwesterly winds, but it's relatively dry. At this point, it'll take a while before we get saturation. Let's go ahead, finally, at 60 hours when that precipitation is expected to start. And it's really light precipitation in the face of this the warm advection beginning to form over us, or occur over us. And we have another little weather system a little bit further south than the prior ones, moving into the North Dakota. Again, I look at this as a really quiet pattern over us. We could take a look, we will take a look just briefly at the GFS for the same time period. Go pivotal, then we're going to look back, we'll go over the Atlantic to see if there's any evidence of the rather deep storm that's forecast. If there's something you'd like to see, please speak up. I'd be happy to.
I do want to show the local temperature, precipitation, snow maps at Toby. He updated them this morning. So.
Okay. So, this is GFS. We're going to go through, let's just jump a little bit forward to the end of the period. And this is not forecasting much in way or any precipitation for that matter. We have a warm advection starting back up by the time we get to Sunday evening. A rather quiet period. If we looked at the 48-hour accumulated precipitation over the weekend, it's very light precipitation over us forecast for this weekend coming up. And it might be with a frontal passage that was forecast. We saw in the GFS, but it's in the MM5, it looks like it's rather weak. In fact, let's take a look at, just to go back to surface map, precipitation type and rate, and go to the 48 hours. Sunday morning, I think I can go a little bit sooner, a little bit further back, 36 feet. Going back in time, there's that cyclone. Again, there's one front through here, and this is now 24 hours, 36 hours. You can see when the front goes by, I guess we get a little bit of light precipitation as the next surge of cool air comes in, but it's not super cold. It'd be interesting to see we could look at the Moss, people want to look at those numbers to see what's going on temperature-wise. But again, a warmer weekend coming up. The weather's going to be certainly decidedly warmer Saturday and Sunday, and perhaps even Monday than it has been today. Let's step back from this for a moment, Pete. Let's go to a different view. Actually, go to tropical tidbits if you don't mind. Go look at the North Atlantic and see the consequences or things associated with the strong jet that John was showing.
Oh, yeah. That must be a big storm.
And also something that's curious that I want to get your opinions, Greg and John's opinion on this. Let's go to the region, lower part of this here, and we'll scroll down a little bit, please. What were we looking at yesterday, John?
North Atlantic. I think it's further down. No, it's not. It's stupid.
North Atlantic.
Yeah, there it is. It's that one. They're kind of in a weird order. So if you
Yeah.
miss it.
So unfortunately, we can't put the cursor over this to see these really intense storms. So this is the 6-hour forecast valid right now. You see this intense region of variability. There's the precip break through the end of this front. But you can see this really intense storm that's located, just to get your bearings here. Something to green right here.
Right about where that cyclone is.
Yeah, 933. Kind of interesting. This one's down into the 950s. Really intense storm. Nice warm advection pattern. And that's I'll admit, that's a beautiful.
It's a nice storm, and no warm front.
No one,
It's
yeah,
just uniform warm convection.
which is like a curiosity with
Yeah,
some
they're,
cyclones.
they're interesting. I don't know what's
Okay.
all about them.
Now, the really interesting storm, was gonna be an 18Z tomorrow, at least starting on, it was Wednesday or Thursday in the forecast. 18Z on, it's gonna go, it's at 24 to what we're at now, 30 hours tomorrow. So we had a really intense storm, and we could probably look at the evolution of that. Here's one, it's 916, run of the mill.
916,
Those happen all the
south of Reykjavik.
Right.
Wow.
And just, I mean, if you're in the British Isles, I mean, this is just really intense winds, just breaking that area with rainfall showers. But we can actually take a look at the evolution. It's a lot of small, intense cyclones. Any of these would be an intense cyclone by itself, but I mean, this is probably the winner. Let's go back a couple clicks.
That's not a polar low.
I don't think they are.
It's too big.
Yeah,
Yeah,
they're
so
in
let's-
the
Let's go back in time. You can see it comes from that earlier one,
Right.
just so I can be in the map. Look at this.
Might have grabbed the polar low in the right creek.
Watch this, 938, 924, of course, in Iceland, 919.
There was the prior time there were 924 and 926, is that right?
I mean, from the prior.
Yeah, look at that.
The 924, yeah.
Look at these two. They're the twin fates or something. I don't know what you call them.
Look at the image, just the thermal structure. of
Yeah,
something.
beautiful.
I mean, this one has almost divorced of any sort of local thermal structure or thermal
Right.
structure to it. Whereas this one is clearly wrapped into it.
It's kind of like a mummy, right? Like there's two eyes here and then like the rest
Yeah,
of the face. is-
I wonder what Melissa's thinking about this.
She's probably, I don't know.
She probably has it on her door in her office.
Yeah.
It's
What's her last name, Melissa?
it's a semicolon.
It's a semicolon.
On the side.
Yeah, on the side.
You gotta reach a little bit to see it.
That's a reach, yeah. But let's continue, just stepping forward this and see if there's anything, any other deeper cyclones that emerge from this pattern.
916. Unbelievable. 970.
And 921, so it's a really deep cyclone.
What's ECMWF?
The second one just goes away.
Unfortunately, we don't have the, I don't think we have the clips for UW. We can go to global and see if it's in there. Actually, yeah, we do have that, but it's gonna be probably much coarser resolution.
I think that's right, yeah.
Not bad. This is 850. I don't think we have surface.
Look at that.
So this is at the beginning. This is from Jersey last night. So this is the actual, the storm that I think eventually develops into it. Jersey last night. Let's step ahead. It's 850 millibars we're looking at, the vorticity associated with it. Wow, it jumps up. Wow. That's 12Z tomorrow. This is out of
It's every 24 hours.
Oh, yeah. It's
So
too
it's really good. But if you go back to 12Z tomorrow, I guess this would be the ECWF model's depiction of that storm that we saw on the GFS.
Yeah,
It's an earlier run.
924,
And then you see these sort of
926.
pinwheeling there. Yeah, rotating. That's a deep storm.
Mhm.
Okay. So I just wanted to show that kind of a neat feature, might be something interesting just to study the evolution of that. But rapid deepener, and it was pretty intense.
This is the fodder for the Viking sagas. If they had been out there on this weekend with their longboats, they wouldn't have come back.
They've been blown back to.
Yeah, that's right.
Hey, all right, so that's what I have to share with you guys. Again, the weekend looks fairly quiet, maybe a little bit of light precipitation with some frontal passages, but certainly a moderation in temperature. Pete has some new maps that he's been working on with accumulated.
Yeah, I'm not quite ready to show those yet. I'm still messing with them.
Oh, what did you want to show then, I guess?
This climate stuff.
Okay.
Where is it?
I'll leave that with you.
So this is the red line is if you take the daily 30-year average high temperature and low temperature and average them by day and don't smooth them, that's what the red and blue lines are. And the black lines are the max and the min for each day. So here you can see, here's our low last night where we got down to, well, it just shows -5. I thought we were colder than that.
Yeah, we were.
Maybe when he ran it, it hadn't gotten that cold. He might have run it in the middle of the night when it was still.
It's also February.
Oh, this is group, this is.
No, this is So it's the temperature, you can see here, 2 cold, relatively cold periods, but otherwise relatively warm. Precipitation above normal for the year. Snow, you can see the snow we had back around Halloween, and then there a big drought, and then caught up since then. So we're above normal for the year for snow.
Yeah, we've had a snowier 15th of January to 15th of February than usual
Yeah.
because the slope is greater than what we actually have.
So So anyways.
All right.
Can we show the jet streams?
Yeah.
I want to show the jet stream plots of these mergers that are going on.
Okay.
Go to the, yeah,
Here's the pointer.
great.
Which one do you want to show?
I don't know if this one's ready yet. Probably not. What's it say up there? No. Try this one. Okay, go to this, just start. So this is the GFS 8-day forecast. And here's what I'm showing you with these jet streams when they merge. And this again, as I point out, is looking at the 40 meter per second contour from above. Plot goes up to about 24 kilometers. So you're looking down into a trough because the top of the jet stream is above the plot. So this three-dimensional surface is going down underneath. And what you can see happening here is with this subtropical jet, and I call it subtropical because it has low stability. You can see it comes down here. This is a 40 meter per second jet, but it has polar jet characteristics on the northern side. This is much higher potential. So this is where it's merging in right here. And what we see happening is that very strong wind you're seeing on the jet streams is occurring right after this intersection, where this subtropical jet really seems to be drawn in to speed up. Now, as time goes by and this intersection maintains itself, where these two are together, that stronger wind seems to build back. In other words, something is happening up here to accelerate the flow, and then that builds back on the jet stream. That's what seems to happen. But anyway, go step ahead. Forward to the 12, what was it, 12Z you were looking at that low?
18Z tomorrow, yeah.
18Z? Yeah, okay, right there. So this is about the time where this low is going on, I think it was up by ice.
Yeah, between Iceland and Tipper Green, right
Iceland
there.
right here. And here you can see this jet stream, you know, this darker color in here is this jet stream, the subtropical jet stream is literally inside of the polar night jet. So the polar night jet is a big jet up high. The 40 meter per second contour goes down, and coming in the side is a subtropical jet. So they're kind of at some elevation merged together. Now the subtropical jet is still stronger below, like you were saying. Then it gets a little weaker as you go up. But then it gets stronger again as you get the polar night jet. So there's a minimum in there somewhere. But the fact that these two things are coming together does not seem to be a coincidence right here. I highly doubt, right around Iceland here, it's a coincidence that this thing is occurring right here. I think the relationship between these two jet streams is everything. And I see this many, many times. I see these two jet streams, the subtropical and the polar jet stream, and the polar night, kind of superimposed where the subtropical is going into the side of the polar night, mainly because the polar night is dropping down. Whenever there's a very big low, almost invariably, there's this intersection going on.
Yeah, I agree. I don't believe it's a coincidence. I just don't understand it yet.
Now, the other thing that's really interesting here that I'm just blown away is we've got another one of these westerly equatorial jets forming. I'm not showing the easterly winds on here. I got some that do show it, but if you just turn that animation on so it cycles through that. Look at this thing. It just pops up. It's not really a subtropical jet. The dark line going through it is the zero potential vorticity. This is magnitude of potential vorticity. So it looks the same in northern and southern hemisphere, but it's the magnitude of it. But this is the zero line. You can see it goes right through the middle of this jet. And
What about that thing in the South Atlantic that comes after it in time? Is that related?
this one?
No.
South Atlantic.
South Atlantic,
Yeah, this
yeah,
one,
yeah, equatorial.
I-
Because it seems to show up downstream in time and space.
There's another plot we could look at. I don't know if I want to go to it, but there's another plot with the easterly flow on it. Go to the Jake plot. There's a Jake plot over there. It's further down the line. You just animate, yeah, this one here. This is at a slightly different contour interval, but the lighter green color is the easterly component jet. And then this would be the westerly component jet. But you see what's happening is this subtropical jet is, I don't know what's that. Actually, can't even explain it. But here we have the westerly flow and then the easterly flow. This easterly flow is from the QBO. It's up very high. And it's odd because it's south of the equator. The equator is right about here. And usually the QBO is right over the equator. So there's this QBO max of easterly flow is a little south of the equator. And then we got these westerly plumes forming on the other side of the equator. They said, I put this online once talking about this westerly jet, and they said it's a breaking Rossby wave, and there does seem to be some evidence of a breaking Rossby wave here, but I don't know how you get that westerly momentum of that magnitude to the equator, because that's faster than the Earth is rotating. Where's that coming from? So, but it is getting this westerly flow here, and then you're getting this kind of westerly maximum building up and kind of spiraling up to higher latitudes as you go around the globe. I mean, that's not that atypical, but we saw this, I pointed this out last year or the year before too.
Yeah,
right?
I remember
It happens at
that,
this time of the year.
So weird.
Yeah,
Mike Ventries at IBM put a plot up yesterday talking about the increase in global angular momentum that's forecast by the models to be occurring in the next week or so. Is that perhaps related to this?
well, there's definitely an increase there.
Yeah, that'd be a good spot to build an increase on.
That's more than the angular momentum of the Earth. So it has to happen through some kind of a wave transport process. Is the only way you can do that.
I don't understand
But that jet maximum has a zero potential vorticity essentially. And yet it maintains a shape like a jet stream, whatever that is. You know, this is the polar night jet. You can see the intersections here now. It's probably because I'm using the 40 something under 42 meters per second instead of 40 meters per second. I think. But anyway, I thought that was that. The
Very
whole
interesting.
QBO thing was interesting.
It's gotta be way out of balance too. I mean, there's, like
Yeah.
you said, it's straddling the zero PV, so there's no gradient across the jet, but there's a wind speed maximum. How does that happen?
Why is the QBO on the other side of the equator? It looks closer to the equator over here. Right? But still, Australia is still in the southern hemisphere.
Yeah, that's
The equator is up here.
right.
In Singapore, that's, yeah. Okay. I mean, I just like looking at these interesting features that I
Yeah, yeah.
can't explain and
I know, there's a
point
lot
them
of.
out.
But these also, as you're pointing these out, these are opportunities that students have an interest in seeing the
Absolutely.
data,
Yeah,
give them some guidance and some things to look at.
That's right, that's for sure.
in my career, I'll never get to this, but it's interesting. I find, well, the atmosphere is just plain fascinating.
Yeah, it is. If
You
you're
can't
bored,
get over
you're zombie-like.
Yeah.
I don't know what else to say.
Well,
If you're
thanks,
bored
Greg.
by the atmosphere.
Yeah, thanks, Greg. And
Yeah,
John
thank
and
you,
Pete.
Greg.
And thanks everyone that's here, but I'll second what John said at the very beginning. Yeah, Fridays are kind of a busy morning for both of us, and so if folks want to step up and do part of a discussion, or you see something interesting, please, by all means, step up and show us what you found interesting over the course of the week.
Yeah.
So thanks for coming.
Thanks. Yeah, you're right, that is interesting. It's just, I don't know much about the QBO.
Well, it's, yeah, I just studied the QBO.